Okay, hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company provide technological solutions across the world. Now, as our today's topic is inventory optimization using deep neural network. Now, see deep inventory optimization exactly in our if you go to our last session, we have learned about session sales optimization, right? Similarly, here on the same pattern, we are today discussing inventory optimization. So inventory optimization means what exactly? Let me give you one example. Let's take a very low level example. For example, if a person who is having a shop, who is running his shop, right? Now it's just a general store, we can say, or just a grocery shop, right? Now what happens here? Every month he has to get some inventory, right, from retailers, right? From retailers or some, what we say, some vendors. He purchase some items which are on large demand. For example, let's take our daily life example, like talcum powder. Now talcum powder and we can say the ice creams, talcum powder, ice creams, and we can say that's it, only two items we take. Now these two items are sold largely in summer season, right? And these things are sold largely in summer season. So what he will do, he will buy that large amount of those ice creams and talcum powder from the vendor, huge amount. And the things which are not used in summer season, which are mostly used in winter season. For example, Vicks inhaler. When a person is suffering from cold and cough, he use that Vicks inhaler or any type of cold tablets, right? So these things are not used during summer season. So what he will do, he will not buy those things from the vendor. So that means he is optimizing his inventory, that which item is largely sold during which season, during which in which area he is residing, right? For example, in winter season, the dates are sold in large amount, and at that time in winter season nobody purchase the ice cream, right? So in this way, every month he has to optimize his inventory. He has to keep track on that inventory, that he should not face the sold out situation, that the customer comes in and he has to say, okay, this item is completely sold out. And there should not be a scarcity, right? So two situations he has to keep in mind, that there should be no scarcity of any item, number one, and there should be no circumstances like sold out, that customer comes to the shop and he says, sorry, this item is sold out right now. So he has to keep those two things in mind, and then he has to optimize his inventory list, right? So once his list is optimized, in that case, for example, let's take an example from NetSuite. I have downloaded some inventory information, right? Now if you see here, this is the product ID, and you can see lead time, stock on hand. Okay, first of all, this is the product ID, as we all know. Historical sales, how much amount of sales this item has done. Then lead time. Now first let me explain you what is the lead time. Look at this. In inventory management, lead time refers to the duration between placing an order of inventory replenishment and the time when order is received in the warehouse. But before that, you should understand replenishment. Replenishment means, look at this. In inventory management, replenishment refers to the process of reordering or restocking inventory to ensure there are sufficient goods on hand to meet customer demand and avoid stockouts example, let me show you this. For example, ice cream or talcum powder, which is used in summer season, right? For example, only 10 items are remaining. At this point, I will order to the vendor. Just a second. Item to the vendor for 1000 talcum powder pieces, right? So replenishment means, see here, replenishment refers to the process of reordering or restocking the inventory to ensure that there are sufficient goods in hand. So this is the point where we call replenishment, right? That means now only 10 items are remaining. At that time we are ordering to the vendor. Okay, now this is clear. Now inventory lead time means refers to the duration between placing an order for inventory replenishment and the time when order is received in the warehouse. That means, again, this is order you have placed, and now this is the time when you receive that order in the warehouse, right? Okay. And reorder level, now let's see, this reorder level also is there. Reorder level, so reorder level is what exactly? Let me explain you. Reorder level is a predetermined inventory quantity that triggers a new order to replenishment stock. It's essentially the minimum stock level a product can reach before a new order is placed to avoid stockouts. That means this is the minimum stock. This is the minimum stock at which it triggers the process of what? Replenishment. The process of replenishment. Just a second. The process of replenishment. This, and lead time is this, right? So now the things are clear to you. Look at this. This is the historical sales. This is the lead time. Lead time means you have placed the order and the item is coming in your warehouse. That is the time. Okay. And stock on hand means whatever stock on hand. Right now we are having 10. This is called stock on hand. Okay. 10. After that, what you will see here, reorder level. Now reorder level means, just now I explained you reorder level. Here it is, reorder level. That means 10. 10 is the reorder level. It is a predetermined inventory quantity. Fine. So now what I am going to do, see, a person who is running a shop or a grocery store, he has to keep track of all these things, and he has to manage all these things to optimize his inventory every time. That means there should be these two conditions, like wastage of product and second, stockouts. To avoid these two conditions, we need to optimize the inventory. Now how this inventory can be optimized using, see, normally in olden days when there were no computers, the person used to use his own experience to do this. But nowadays what we are doing, we are just giving the historical data to the machine. This is total 1000 rows, right? So this is the historical data that we are providing to the machine, and then with the help of some algorithm, it will detect that which order you should buy in which quantity, right? For example, in my store, talcum powder is stored, just a second, yeah, for example, in my shop, talcum powder is sold every day. 10 to 20 pieces are sold every day. Now such type of data if I put into the machine, definitely that algorithm will suggest me that you should keep talcum powder pieces into quantity of 10,000 in your stock, right? Because in summer season, for the 4 months of summer season, you will get so much sales, right? So this is how we need to understand. So this is what the scenario that I have explained you. In this type of scenario, this will be used in every, I have explained you about this very small shop, right? The very high level businesses like D-Mart, the Big Bazaar, all these retail chains, they also use this technique to optimize their sales, because each and every person will not keep track that okay, this season comes now, which people will buy which item. Here human intervention is less. Only each and every data, there are thousands of rows in the Excel sheet, each and every data is converted into the Excel sheet, and that Excel sheet is given to the deep neural network machine, and that machine will tell you that okay, this time. So without taking human help, you can do it in few hours, within an hour, right? So this is how inventory optimization is done. Now let me explain you what is inventory optimization first, then we will move ahead. Now see here, and that is why we use ERP data, because huge amount of data. Normally if a person is running very small shop, he does not need that, because his shop covers only those local colony people, right? Colony families. But here if we are talking about like ERP system like D-Mart, Big Basket, Big Bazaar, or any grocery online facility, Amazon, so they use this type of algorithms to optimize their inventory, that people should come in the shopping mall and they should not face the situation like this item is not available, right? So that is why it is used here, right? Now the idea is clear why we are doing this. Okay, now inventory optimization is a strategy that helps business maintain the right amount of goods to meet customer demand while minimizing cost and maximizing profitability. That means minimizing that stock which is not used today and maximizing that stock which will be likely to be used maximum by the people. Okay, so there are so many things. For just take an example, in an area, like in an area where there are like near about 70 to 80%, 70 to 80 children are below 15-year-old, right? In a colony, a person is running a shop and where 70 to 80 children are there which are below 15-year-old. So what he will do, his machine, he will do without machine also, he can predict that okay, I have to keep the stock of biscuits and chocolates, right? Same thing is cookies and chocolates. So same thing is here. The machine will tell you exactly which item should be brought in which amount, okay, in what amount. So here the idea is clear now. Okay, forecasting and planning, 6 tips for optimizing inventory levels. First is forecasting and planning. Second is maintain safety stock. Maintain safety stock means the whatever you have brought, it should be sold out. It should not like this much item is remaining, now again we are sending to the company back. That is called keeping the safety stock. Set reorder point. Yes, reorder point means almost suppose 10 quantities remaining and I know that within next 2 days these 10 quantities will be sold out, so I have to buy this today only from the vendor. Fourth point is economic order quantity. Economic order quantity, fine. Monitor inventory turnover, yes. And then regular inventory audits. Regular inventory audits means how much items are sold, how much items are brought, and then how much remaining, all these things. Then importance of inventory optimization. The importance of inventory optimization is that enhanced customer satisfaction. Now customer satisfaction means exactly what? See, if you go to any shop and whatever you wanted, if it is available in that shop, that means you are satisfied. And imagine if you are going into a shop and the owner is saying that this item is coming next week, next time you will not go into that shop, right? So that is called customer satisfaction. If each and every item is available in your stock, definitely customer will be satisfied. Second, reduced carrying cost. Reduced carrying cost, whatever items if you purchase in bulk, it will reduce your carrying cost, that means the whatever the transportation cost. Efficient production planning, yes, efficient production planning is one factor. Improved cash flow, fine. Minimize the stockouts. Minimize the stockouts means the same. Stockouts means your stock is running out of the item is running out of stock, like that. Better supplier relationship, yes, when you are purchasing accurate items and in bulk, so you don't need to bother that vendor each and every time, bother that supplier each and every time. For example, if I know that in my area pencils and notebooks and stationery items are sold out in huge amount, so definitely I will buy sufficient amount from the supplier. So it will make a good relationship between the supplier and the, because every supplier wants that his buyer should buy huge amount of product, right? Enhanced demand forecasting, yeah, we can forecast the demands also. See, PyTorch is used in every field, whatever, wherever you want to predict anything, it is useful, right? Now see here, benefits of inventory optimization. Number one, improved cash flow management, okay. Enhanced customer service, we already discussed. Third is minimize stockouts, we discussed. Efficient product planning, fine. And reduce the lead times. Again, reduce the lead times means it will reduce the lead time. In a given time, if you buy this particular item and it will come, you know that within next 2 days or 3 days the item will be received in the inventory, right? So how does inventory optimization work? See, inventory optimization is a strategic approach to maintaining the ideal balance between supply and demand, ensuring businesses have the right stock at the right time while minimizing excess inventory. Excess inventory means, don't do like this, that the item which is not sold and still you are buying that item in huge amount and you are just occupying the space in the inventory in the store. So we should not do like that, right? So again, same thing, forecasting demands, setting optimal inventory levels, okay, stock allocation optimization, replenishment strategies, all these are things. Supplier collaboration, fine. Inventory segmentation, it is just like it is something related to like bin numbers and that area number, so that is in depth in the inventory, so we will not go in that. Performance monitoring and adjustment, okay. Now see here, inventory optimization using DNN, deep neural network. How deep neural network will do this? Now see here, model and process workflow. First of all, historical order data collection, okay, then data pre-processing, then training and testing, then DNN model. In this DNN model, it will run the epochs, whatever we were doing for the last few sessions since beginning. So here DNN model is there. Back propagation means again repeating the same process, then product popularity prediction and evaluation and comparison. This is how the complete process works. So now I am going to show you by by practically. Now again I am doing one more iPineapple interactive Python notebook, okay. Now this I have already done here. Let's minimize this first. Now first of all, see, by doing this in machine language, deep neural network, we need to first install the libraries only, right? So we have to first install the libraries, and pandas very well known library, numpy also used, torch, NN means neural network, matplotlib for plotting the data, train test split for this, and then the sklearn, min max learn. So scalar, it's a scalar we have used the scalar. I will show you how it is used. we need to wait. Okay, now it is, libraries are loaded. Now I will do one more thing here, just a second. I will close this now, no need. Okay, don't save. Okay, now I will read this Excel sheet, right, CSV sheet. And now if I put df, now look at this, product ID is not used, historical sales, lead time, stock on hand, reorder level, demand forecasting. Okay, now what next? Now look at this, we have dropped the column product ID and demand forecast, which are of no use. Okay, and then demand forecasting is a dependent variable, that is what we need to forecast. So what we have done, we have taken only limited and useful. So in X you can see the independent data, and in Y you can see all the dependent variables. Okay, look at this, 210, 99, 193, 210, 99, 193. Okay, so what we have done, we have done like this. Now we are going to normalize the data. So normalize the data, actually what it has done, look at this, it converted the data into -1 and 1. So whatever the machine understand it, normally we don't understand. For example, if the alphabet A is written, right, alphabet A is written, now this A will not be recognized like we recognize. In machine it will be first converted to tensor, it's a matrix, and then it will be read by the machine, and then it will come to a conclusion that okay, it is written A. Okay, now same thing is here. If I do y underscore scale, okay, now split function. Now see here, X train test and Y train test, train test split, this is the library we have used here, train test split. Okay, now X scaled, Y scaled, test size is 2, that means 20% data is used for testing and 80% for training. Random state equal to 0. Now this random state, let me explain you about this. See, train test means 80% training and 20% testing, means a child keep on reading his syllabus books, course books for the whole year, but at the time of exam only 20% of the syllabus is asked. They will not ask you each and everything. 30 to 40 questions are picked up from every subject, and then they are asked in the paper. Same thing here also, right? So now if X underscore train dot shape, 800 are the rows and 4 columns that we have used here, right? Similarly, X underscore test dot shape, look at this, 200 rows and remaining 4 are the columns. So this is how we have distributed, we have splitted the data. Now convert to tensors. Our next task will be converting data into the tensors. Look at this. So now the data is converted into tensor. Tensor is nothing, it's a what we say, the array of that item, right? But that array, you can't read that array, only the machine can read the array. Okay, for us it is sufficient to know about the array and tensors. Okay, now what we need to do, look at this, we have created one init functions. Okay, now here review, and I will explain you again, same thing. Suppose whatever the data is given to the machine, right, that machine will create 64 neurals, and then that neurals will be processed, and after that review activation function, it converts all negative into 0. Okay, negative values into 0. Again, second time what it does, it creates 32 neurals, and at the end you will see 32 neurals and only one one item is remaining, that is either yes or no, or whatever the answer it could be. And here you will see the forward, we pass the data into the function. Okay, this is just technical part. Now I will show you now. Look at this inventory NN, it's a function. Inventory NN, look at this, it's a class. Now what we have done, we have calculated MSE loss, mean square error loss, which is the difference between the actual and the predicted, and then optim Adam, right? We have used this optim Adam. Now what we need to do, our as usual task, that is epochs running. And now what we need to do here, you will see epochs is 200 times, and now we are increasing the accuracy of the model. Same thing, increasing the accuracy of the model. In one attempt we can't increase the accuracy. As the number of epochs it is running, it will increase the accuracy. You can see here the loss is 0.0077, then it reduced to 0.0016, and then again it reduced to 0.0012. So in this way the loss is reduced, right? Now look at this, predict on test. Now see here no grade is used, that means we don't want the back propagation. Right now we are evaluating. Now evaluation is done on 20%, right? Not the whole data. Same thing is here when we are evaluating it. So torch dot no grade, no gradient, and then y underscore predicted scale, all these x test testing data is passed in this model. Okay, now you can see here torch dot no grade, and then y prediction scaled, and y prediction, and y actual, whatever we have received here, right? Now what next? Now you will see here now these are some data. Let me show you what type of data is this. Yes, now you can see here historical sales is 150. Let me run this first, then only it will be clear to you. Just a second. Okay, now see here actual, predicted, future, and forecast start. Okay, now see here, if I make it as historical sales at this much high, then look at this historical sales, actual demand. Right, so what we are trying to say that here you have put some different inputs, and then future scaled equal to scalar dot transform, that means we are again transforming the data. Then future tensor equal to torch.tensor and then future scaled. Okay, after that with torch no grade, that means we are not using back propagation, and then future prediction scaled equal to model future tensor and then failure prediction, that is future prediction, that is scalar y inverse transform. Inverse transform means we are again converting that data into the human readable format and understandable format. Okay. Now here you can see plot actual, predicted and future. Now you can see here we have plotted the data and we have, just a second, we have to run this from here. Then we do this and then we do this. Now see here, actual, predicted, future and forecast. All these data, they are overlapping each other. That means our model is accurately correct. Now what next? You will see here now if you see the item which is 150, historical sales, lead time is very less, stock on hand is 80, and here you will see one reorder level is 100. For example, our item which is sold 1500, right, lead time is fine and stock on hand fine and reorder level is 100. Let's check it out. We are doing it for inventory item 1. Okay. Look at this first item. When I am saying to the machine that okay, this item is sold in such a high quantity, historical sales is 15,000, lead time is less, which is good, 80, stock in hand 80, and reorder level is 100. Now what it will do, it will suggest me that okay, bring those items into 14,796, right? So in this way we can predict. For example, let me take one more example. Suppose historical sales is only 70, only 10, and reorder level is like, let's take 4 only, and reorder level is okay, fine. Now what I will do, enter, see which item that we have kept. If you see the second item 10,4,4,110, so what it has suggested me, only bring this 69 quantity only, not more than that. Keep only 69 items in your stock, that is sufficient. So in this way what we need to do, we need to understand exactly how it relates with daily life and how it will help you in your future forecasting. Clear? So now let's take a quick recap. First of all, the scenario is clear to all of you that we are optimizing the inventory to avoid those two conditions, that is wastage of items and wastage of place, and then second is sold out, right, sold out situation. So we need to avoid these two things. First of all, we have imported all the libraries we needed, then we read the data set, then we removed unnecessary columns, then we splitted that data frame or the data table, or we can say the data set. Then we have done or normalized it in the format of transformation, and we transformed it into -1 to 1 values which machine can understand. Secondly, we should split the data into train test split, right? That is what we have done. Convert to tensors. After splitting the data, they are converted to tensors, and after that you will see here there is a function, predefined fixed function, which is used here. So 44 is, so we can see whatever you have train test model inventory and right. So we have done this. After this, what we have done, we have executed the epochs, and with the help of that, this is called the training of the machine, and then with the help of that epoch we found whatever the losses are there, and the machine is now trained itself. Then we will see the model evaluation. Now you will see here model evaluation. Here we have used only 20% data, which is useful for us. After that, you will put some historical data, and you can make changes in this data to understand better, right, as I have explained you in this. After that, you will see future scale. That means whatever the data for the future is again now converted into inverse transform, means again converted into its original format, correct? Then we have plotted the figure like this. Okay, so guys, this is another most important topic which will be used everywhere, right? Because every company has its own inventory, and in the inventory they want to predict such system. Instead of asking the department heads that how much is required or how much is over now, right? So I recommend you to watch this video twice, thrice, and then if you have any issue, in that case you can reach out to me. You can put the question into the comment box, and then I will explain you. Okay guys, so watch this video at least twice, thrice, then only it will become clear. So guys, thanks for attending the bootcamp session, and those who are new to this channel or those who have attended it recently, so please like and subscribe the channel. Okay, so guys, in our next session we will see something new topic. Okay, so keep practicing. Thank you. Thanks for attending the bootcamp session. Thank you.